to the Daly shaft. Now that tunnel cost $200,000 in 1880 dollars. That's about $5 million today. And in 1883, the famous Cornish pump was installed on the 600 level. That would raise the water up to the surface and out of the mine. That pump cost, as you can see the numbers there, a lot of money, 17.2 million in today's dollars. It was a huge machine. Flywheel wheel was 30 feet in diameter, weighed 70 tons. It was cast in Chicago, I believe, and shipped in pieces to the mine. The pump rod was 1,060 feet long, made out of 16-inch square timbers held together with iron bands, and it could lift some 2,500 gallons of water per minute with a 10-foot stroke. So it worked well for a while, but eventually more was needed. There's a picture of the Cornish pump. It was a one-cylinder steam engine that just chugged away. If you ever get a chance to go to the old mining district in Cornwall in England, they have restored a number of these pumps in the engines. It's really interesting to see how they worked. So there were a lot of tunnels in Park City. I just chose the 4 or 5 largest ones to give you an idea here. The number 1 tunnel was driven in 1881. It was eventually over 9,000 feet long. The Daly Judge Tunnel, also 1881, 10,000 feet long or more. The Ontario number 2 tunnel ended up being over 3 miles long, or almost 3 miles long, sorry. It was perfectly straight. And then the Alliance or the Anchor Tunnel came along in 1889, and the Snake Creek Tunnel, 1910, and the Spiro Tunnel in 1916. That's a picture of the Spiro Tunnel there on the right. So the fact that so many tunnels were driven just tells you that water was always a challenge in the lower levels of these mines. When you think about tunnels, I don't know what you think of. This is a modern day tunnel put in by the Italians and the Swiss in the Alps. It's called the Gotthard Tunnel. It's very clean, dry, well lighted, and nicely set up for two-way rail traffic. But most mining tunnels look more like the one you see here on the left. This is one of the drainage tunnels in the Rammelsberg mine in northern Germany. This mine started operating in 900 in the Common Era, and by 1150 they had put in the first drainage adit. An adit's another mining term for tunnels. If you're a crossword puzzler, you know the word adit. But the first tunnel at the Rammelsberg was 900 meters long, and they were able to advance at 20 centimeters a day. The combination of hand drilling and fire setting, we'll talk about that. It took them 30 years to complete it. In 1486, they drove another drainage adit 45 meters lower. It was 2,600 meters long, and it took them 99 years to complete it. I've often thought how it would be to be the mine manager, to go to the company CFO and tell him that we've got a capital project starting and it will take 99 years to finish. I think there was a different conception of time in those days. But the second drainage tunnel really improved access to the ore bodies at deep levels, and the old books say that after that tunnel was completed, the miners swam in silver. The Rammelsberg mine is another great place to visit. You can see a photo of it current day on the right there. It's now a UN World Heritage Site, and you can take tours there and even go underground if it ever gets to be a time when we can go back to Europe again. So the methods of tunnel setting for many years started out, of tunnel driving, they started out with fire setting and hand drilling. On the left, you see an illustration from Agricola's mining textbook in the 1500s. The miners would carry down as much wood as they could and stack it against the rock face, set it on fire, get out of the smoke as best they could, and wait till the fire burned down, and then throw cold water on the heated rock face, and the rock would fracture and they could advance the tunnel, 18 or 20 centimeters each day. Lots of miners died young from smoke inhalation using this method. Later on, they started using hammers and chisels, or in England, they called these a hammer and gad. In Germany, it was called a Schlegel and Eisen. But the idea was you have a steel or a bronze chisel, and you have a hammer, and you beat into the rock until it breaks and falls in. This was hard work. In a lot of mining countries, this is known as single jacking. That's what it was called in Cornwall. You can see some fellows doing that there. Here's a photo of men single jack drilling in the Ontario. This picture was posed, of course, so they looks like they all even washed their faces. But you can see the man in the middle is breaking up some coarse ore that's been knocked down, and the fellows on either side of him are trying to drill upwards. And if you've ever swung a 4-pound hammer and tried to swing it up and hit a steel, I can do it for about 20 minutes, then my arm gives out. So these guys were strong. You also notice the candles and candle holders that were stuck into cracks in the rock. And it was hard work. And bear in mind that typically in Park City, till the state changed the law, the miners worked 9 hours a shift at the face, and they weren't paid for their travel time. And when they were working in wet entries, they also were required to provide their own rain slickers and hats and rubber boots. This photo is from the Dulcoth mine in Cornwall, but it's a good illustration of what they call double jacking. That's where you had 2 hammer operators or hammermen and one fellow holding the steel. They're swinging 4 or 8-pound hammers with 3-foot handles on them. And I think the bravest man in that photo is the one holding the steel. Because if the hammerman missed and hit him in the hand, it was a bad day. About 1880, the steam drills started coming into the mines. This is a drill called a linert. And a lot of times miners called them liners. That linert was a fellow who invented it. You can see that this one is set up on a pipe that's stood up in the mine entry. It has a thread at the bottom for some adjustment, and then it's wedged in at the top, so it's tight. And then it has a universal fitting on it, so it can be rotated in 2 axes and swung around the pipe, so they could drill a number of holes from one setting. Now, bear in mind that this drill weighed almost 300 pounds, and the pipe was also heavy, so putting the drill in place was a big job. You can see that the man standing near the face is holding a hammer. That's because the drill steel often got stuck in the hole, and the helper had to beat on it to free it up so it could keep drilling. A couple of other things to notice. You can see the steam line coming up kind of on the bottom left up the pipe. In front of the drill operator's leg, there's a water bucket, and this drill drew water out of a bucket and kind of sprayed it up near where the drill was drilling to try and keep the dust down. You'll also notice that the drill operator is turning a crank handle there with his left hand. That actually moved the drill forward as the hole was drilled. This drill just banged against the rock face and rotated, and gradually the hole was advanced. So these drills were used for a long time. After the holes were drilled, it was time to blast. And when they started on the Ontario Tunnel, they were using black powder. It was always exciting to load black powder into the hole because a spark could ignite it. So you'll notice these fellows are pushing the powder into the hole with a wooden stick. Wooden and copper tools were common when blasting with black powder to avoid ignition. And until the safety fuse was invented in Cornwall by the Ensign Bickford Company, they used fuses and just made them as long as they thought they could get away with, so that they could make a decent escape from the face before the round went off. After the round was blasted, we're left with a big pile of muck or broken rock in front of the rock face. This is a photo of mucking. This is in a Michigan iron mine, but it's a good example of how mucking went. Sometimes the rock would break in big pieces that were too big to pick up. In that case, it was hammer time again to break the rock until it could be picked up and put into the ore cart. Finer material had to be shoveled. It was difficult work. After the ore cart was filled, it was time to haul it out. This is on the haulage level in the Ontario. This man's pushing a 1-ton ore cart. It's on steel rails, so it moves relatively easy. And these would be pushed out to the next stage. We'll see that in a moment. But all of the haulage in the Ontario was eventually done by mules. And you can see here, this mule is hauling a crew out of the mine. Even the mule is wearing a raincoat. So the mules did a lot of work in the mines. The ore cars were eventually delivered to a shaft station. You can see a number of them lined up here. This is at the bottom of the number 3 shaft. R.C. Chambers, who was the manager of the Ontario for many years, is there in the center holding the lantern. And you can see that These ore cars are on the right-hand side as we're looking at it. That's the side of the shaft into which the ore cars were loaded. And then people were hoisted and let in and out of the mine on the left-hand side. This is a good photo of how one of these shafts operated. This is in the Daisy mine in Butte, but it shows this shaft actually had 4 levels. So you can see 4 levels of men stacked up, waiting to go down into the mine. And then on the other side of the shaft, there are 4 levels of ore cars that have been emptied out, and they'll go back down to be refilled. The workers and the ore cars were hoisted in separate compartments in the shaft because if there was an accident or something that caused an ore car to break loose, we didn't want men beneath the ore car to get injured. After the face was mucked out and the ore was hauled away, it was time to install the timbers. For many years, timbers were the only real way to support the openings underground, and so timbering became quite an art. Although it was an art, it was still hard work. This is a photo at the mouth of the Ontario Tunnel. After it was opened up following the cave-in in 1904, and then they made it wider so they could have 2 tracks in there. But you notice that there is a lot of timber in there, right? And these are 12 by 12 inch timbers, and you can just see there's a big line of them. They were put in mostly in the Ontario number 2 tunnel. The timbers were on 5-foot centers. So the timber sets in Ontario were a standard design. This is the title page of Peel's Mining Engineer's Handbook from the 3rd printing. The first printing came out in 1915. And for tunnel sets, it showed a design like this one. We had 2 posts, 10 by 10 inch by usually 9-foot posts, one on either side of the tunnel. On the top of that, there was a cap. This one shows a 10 by 10 by 6-foot cap. And then there was lagging on the sides of the and the top of the timber set. The lagging was usually 2 by 10 or 3 by 10 inch side lagging. And that lagging prevented loose rock from falling in between the timbers and into where people were working or hauling ore. Most tunnels had water in them, and this one was designed with a water ditch so that they would put in these slabs a certain distance up on the side posts. And then those slabs supported the sills, which were either 6 by 10 or 6 by 6. And the sills were also the ties for the railroad. So they had to be installed level and on grade. And the rails went on top of the sills, and more lagging went on the sides and in between the rails for people and mules to walk on. So, you know, this is a fairly simple design, right? And if the timbers were all pretty much cut to length outside, all they had to do was put them in. As I mentioned, the dimensions were a little different in the Ontario Tunnel. Lagging was 5.5 feet. And the sills were 6 by 6 instead of 6 by 10, but that's pretty much what it was. But what I'd like you to think about now is how heavy this was. A 10 by 10 inch by 9-foot post weighs over 200 pounds. The cap weighed more than 170 pounds, and each piece of lagging on the floor weighed 106 pounds. There were no forklifts in here to lift timbers. There was not an overhead crane or anything else. All this timber and these rails had to be handled by hand and put in place by hand. So you might ask yourself, how do you put a post that weighs 210 pounds up against the wall of a tunnel and then put another one on the other side and hold them in place while you put the cap on? The Mining Engineer's Handbook doesn't explain how to do that. At least I've never seen one that does. But from talking to some old timers and looking at some old drawings and photos, I think what they did is after they blasted the round and they got a big pile of muck in the tunnel, they didn't muck it all out. They left material in there that they could stand on as they put the timbers in place. I've also uncovered some old drawings that show how they would put in temporary slabs along the sides of the timbers that were in place that they could put other lagging on and stand on that as they erected the higher timbers. So it was a task that required some skill and a lot of strength and endurance. And something we should remember when we read about these fellows that were working there for $5 a day. This is an interesting photo from Butte. It shows another way of handling timber. You might see a big timber and think, well, one guy picked up each end, but quite often they just drive the pick into it and drag it along the floor. And I thought that was interesting to see how that worked. The mines in the West used thousands of board feet of timber. This photo is from Carson City near the Virginia City mining district. But all of the timbers for that mine came out of the Sierras down to a flume that terminated in Carson City. And there they cut everything to size and took it up to the mines. You can see how much timber is stacked up there waiting to be used in those silver mines. If you look at old photos of the east side of the Sierras from Carson City on south, in the 1880s and 1890s, all the trees were cut down. There were none left standing. There's one interesting thing that I noticed in the Ontario number 2 tunnel when I visited there in 2001, and that was the way they set the lagging in place. We'll talk in a little bit about the soft ground and squeezing ground that they encountered in this tunnel. But to compensate for that, between the posts, the side posts and the lagging, they put in these little, I don't really know what the miners called them, but they're about 2 by 2 inch square, tapered out 3 inches long. They would set these little pieces in place between the side posts and the lagging. And then what would happen is that as the ground swelled and moved, those little V-shaped pieces would kind of yield and fail and allow some relief of the strain in that soft ground, and the lagging would last longer and the tunnel wouldn't cave in. Now, I have no idea how they got those in place and held them there while they put the lagging in. I tried to knock one loose and see how it worked, but I couldn't see it. So I've never seen that anywhere else, and it's quite interesting. Once the timber sets are in place and the sills are in place, then it's time to put in the rail. I haven't been able to find any photos of workers standing rail underground, but the mining students in the US and throughout the world have competitions every year where they practice these old arts, and one of the competition events is rail standing. So you can see this is a day outside where the ground is level and there's no water. But in the competition, they're required to put down the ties, make sure that they are level and straight, and then they have to put the rail in place and make sure that it's set to the right gauge. In the lower photo, you see a fellow there with a gauge bar at the end and make sure the rails are the right distance apart. And then the other guys are using these long kind of pointed hammers to drive the spikes home into the ties. And that all has to be done while the rails stay at gauge and on level. So it again required some skill. Once the rail was in place, it made it a lot easier to move materials and people and everything else in and out of the mine. So now we've talked about the labor and the art and skill of driving a tunnel. Let's talk about the Ontario a little bit more. You probably know or have heard that the Ontario outcrop was discovered in June of 1872 by 3 men, Rector Skeen, John Kane, and Gus McDowell. The outcrop, when they had it assayed, ran anywhere from 100 to 400 troy ounces of silver per short ton. That's an incredibly rich silver ore. A rich ore nowadays for silver is maybe 10 or 15 ounces per ton. So everyone knew that this was the possibility to make a lot of money. And the discoverers sold the claim about 5 weeks later to a man named R.C. Chambers, who worked for the Hearst Syndicate. And he paid them $30,000 for their claim. And that's equivalent to $750,000 today. And he was appointed as the manager of the mine. R.C. Chambers is identified in that photo. George Hearst is on the right. And you're probably familiar with him because he owned mines in the Black Hills of South Dakota and in Butte and all over in Virginia City, and became a very wealthy man. The mining company was incorporated in 1874 in California, 50,000 shares at $100 each, and work began 12 days later on developing the mine. In 1883, they put in shafts numbers 1 and 2 and 3, and the drain tumble number 1 was already in use, and the Cornish pump was installed. By 1886, they had stoped out 125,000 square yards of ground. Stoping is another one of those mining words that means they had just dug out 125,000 square yards of mostly of ore, rich silver ore. And we'll look at this map in more detail on the next slide. This is a geological map overlaid on a topographic map that was done by the U.S. Geological Survey. A fellow named Boutwell and his team spent 7 years in Park City preparing a report. And they came back and they had photos of all the fossils. They'd mapped all the outcroppings. They'd mapped the topography, all the mine workings. It's incredible to me the work that these men did in those days. But you can see here how these mines are laid out. Most of you are familiar with Empire Canyon coming kind of down across from the top right to the left. And then just across the hill is the Ontario Canyon. This was kind of a divide in the district. They were always talking about the mines on the east side and the mines on the west side of the hill. And the Ontario and the Daly Judge and those properties were all on the east side. You can see down there in the lower right, the shaft buildings for shafts number 1 and 2, shaft number 3, and then you see some other features there as well. This map is particularly interesting. It's also from that report by Boutwell. This one is folded up in my copy of the report, and you have to handle these old maps carefully, but it's quite interesting because what they did is they took the survey data for all of the underground workings in 1909, and then they projected them all onto one surface. And if you look closely, you can see some of the lines are red and some are yellow and some are blue. Those are the different levels at which those openings existed. So again, you think about people are going in and surveying all these openings, and you'll see that not many of them are straight, right? So to survey them, they had to take a lot of readings, and then they brought those back up and transferred them onto this map. So if you kind of look where we are, that arrow on the left shows the Daly Judge Tunnel, and it runs out by the Massachusetts mine. There's the Daly shaft number 1 and shaft number 2. There's Ontario shaft number 3. Oh, sorry. Yeah, that's number 3, and there's shaft number 2, and it's covered up here. I can't see it, but right on the right, it shows the Ontario drain tunnel going out. So in 1886, the Park Record recorded that the Ontario ledge, which was the big ore deposit, was open for about 6,000 feet. It says about $20 million has been taken from this ground, nearly half of which was paid in dividends. Okay? A number of unusual things about that. I didn't convert those $20 million in 1886 to present day dollars. You can just divide by 0.04. So you can see there's a lot of money taken out of this, but it's also interesting to me that half the value of the ore that was mined in those first few years, half of that was paid out in dividends. Most corporations don't pay dividends like that anymore, but that was a different time. The other interesting thing to notice is if you look closely, down here around the Daly Judge workings, I hope you can see my cursor, and then up in the Ontario workings, all of the underground workings are kind of concentrated close together, even though they're on different levels. And that's because the ore in most of the Park City mines was deposited in fissures that filled up with intrusive fluids that carried minerals. And those were often called ledges by the miners. Sometimes they're called ledges. In Cornwall, they were called lodes, different terms for them. So what they're really doing is sinking shafts and driving tunnels and trying to get into these ledges that had the rich ore in them. And when they did, they made a lot of money. So the record recorded or reported that in 1888, July 21st, there are 7 or 8 men clearing brush, grading for buildings, and 20 men will start hand driving the tunnel. That means drilling by hand till they get compressors and boilers. They also hired a man named John or Jack Keetley as the superintendent. Keetley had been working in the Marysvale district down in central Utah, and he had the reputation of being a good tunnel man. I found one interesting thing about him, amazing what you can find on the internet. He was apparently the only Pony Express writer who wrote for the Pony Express during its entire existence. And he said his greatest performance and one of the most remarkable ever achieved in the service was riding from Rock Creek Station in Nebraska to St. Joseph, Missouri, and then on to Seneca, Kansas, and from Seneca back to the Rock Creek Station, a total of 340 miles without rest. He rode for 31 hours averaging 11 miles an hour. And during the last 5 miles of his journey, he fell asleep in the saddle, which tells you that not only was he a good rider, but he had a good horse, right? So Keetley was a man with a reputation, and he did the job. On August 9th, the park record recorded that the tunnel was advancing 2 feet per day in 130 feet, and they're already making, that means they were producing 200 gallons a minute of water. And in October 1st, Superintendent Keetley married a woman named Maggie Oldtree. By December 1st, the boilers were up and running, and they were in 280 feet, expecting to advance 75 feet per week. As you'll see, that was optimistic. So just to hit some high points here now, January 5th, they're in 300 feet in soft ground. Took them 7 days to go 50 feet. They're back in shooting ground. That means they could blast it. February, they were in 700 feet. You can read these: soft ground again, running ground. Soft ground means the ground would gradually move after it was timbered. Running ground meant that it flowed like sand or gravel. As I went through the park record, pulling out this chronology, I found some interesting things. 1889, there was an entry that says 5 of the girls on Heber Avenue. Does everybody know what was on Heber Avenue in Park City? It was the red light district, right? 5 of the girls on Heber Avenue were arrested for using vulgar and obscene language in public during the week and fined $10 each. So it was an interesting place. By November in 1891, they were in 1,000 feet. They'd made 60 feet that week, and they had lowered the floor to keep the tunnel on grade. So Keetley and his surveyor were working and keeping them on track. 1892, progress continued, no decrease in water flow. On March 5th, a man named Lee Colson was killed. He was a timberman, but he was repairing the track at the 1,000-foot point into the tunnel. And they'd had a lot of water flowing, and it had loosened up the rock on the sides of the tunnel. And a big boulder rolled out of the rib and pinned him against the track. As he struggled to get loose, it kind of settled into him. They took him out and took him to the hospital in Park City, but he died of internal injuries. The record recorded that Colson was a Swede who had 3 brothers, 1 in Idaho and 2 in Montana. And none of them were able to come to his funeral, but it said the men employed at the tunnel turned out in a body and followed the form of their departed friend and fellow workman to its last resting place. As far as I can tell, that's the only fatality that occurred while the tunnel was being driven. So by the year-end report in the park record, it said the tunnel was in better ground. It was in almost 11,000 feet. And recently they had advanced 5 feet in bad ground, and it took them 5 weeks to advance 5 feet. I also mentioned that a new bunkhouse had been built at the tunnel mouth with a full kitchen. And this was interesting to me. The record reported that a new feature has been introduced in the matter of feeding the men on the morning and 3 o'clock shifts. The dump man takes the boys' dinner into them and spreads it out on a table at the big station and sounds an alarm by tapping on the air pipe. The boys come out, sit down to a good hot meal, and when they are through, the dump man cleans up the remains, removes the dishes, and the boys go back to work. It's a great saving of time and gives the men better satisfaction. The tunnel is a great institution, and Mr. Keetley is making a sound addition to his already good record as a thorough manager. He anticipates no further trouble from soft ground. You'll see that that was not the case. But the park record made regular reports on the progress of the tunnel because it was very important to the economic conditions in Park City. So in 1893, they were in bad ground and in good ground. And you'll notice that in March 4th, they said the record reported they were close to number 2 shaft. In August, they were still close to number 2 shaft. In November, they were closer to number 2 shaft. And finally, by December, they'd gotten past number 2 shaft and were close to the number 3 shaft. 1894, bad ground again, 23 feet per week. March 10th, the record reported that 12 men were working full time to keep 150 feet of the tunnel open. That was around the clock, okay? And by April, they could not work at the face because a stream of water the size of a man's body with the force of a fire hose was shooting out of the face. Nobody could stand up. They brought in crews to re-timber the worst 600 feet of the tunnel, And they weren't using the 10 by 10 inch posts by then. Those were cut up in the Uintas. They brought in 18-inch rounds, they were called, and these were just big logs from Oregon. And the cost of that work was $3,000 per foot, which is equivalent to $75,000 in today's money. By May 4th, they had that under control and the water pressure had decreased. Work resumed at the face, and they were only pumping 1,200 gallons per minute. But there was so much water in the tunnel that it limited how much ore they could haul. Each mule could only haul 2 cars per day. Normally a mule could haul 15 cars per day. But the water was so deep that the mules couldn't make it. So on June 9th, on 1894, the man from the record, as he called himself, visits and reported that the tunnel's in 11,030 feet with 900 feet left to the number 3 shaft. He commented that daylight was visible at the face, and it was pointed out that Mr. Keetley has his own special method for maintaining alignment. If you were lucky enough to hear Dr. Kim McCarter talk about surveying in Park City in February, he explained Mr. Keetley's method. It was quite a thing. So 1894 continued. There was bad ground again. The record reported that on July 7th, there was a baseball game at the tunnel grounds, as they called it. The tunnel team played the Park City second 9. And in the 9th inning, the score was 19-19, and they called the game on account of darkness, promised to meet up again later on and finish it out and see who won. July 28th, there was a new schoolhouse completed at the tunnel. There were quite a few people living there. They held a dance to celebrate it. August 4th, they were close to the end. 11 timbermen were let go. September 8th, only 415 feet left, but now they were in what really hard drilling ground. Required 12 to 18 hours to drill each round. A round was typically 6 feet, so they would probably drill 8 or 10 holes in the face, and it took a long time to do that. The drills, so they said they would hitch in the holes. That means they would get stuck to the point where they couldn't pull them out, and they just had to start a new hole. But on October 7th, the tunnel was finished. On October 13th, it was said that the young people, aided by the married ones, gave a grand ball at the tunnel mouth, and the demijohn was passed around. I wasn't old enough to know what a demijohn was. I had to look it up. But there you see a demijohn. It was reported to be a large vessel with a narrow neck for containing wine or other spirituous liquors, often wrapped in wicker to keep it from breaking. I guess if you pass that around long enough, somebody was likely to drop it. So that's the demijohn. So let's just talk for a minute about, what do we mean by bad ground? One report in the record said the ground was so bad it required 2 months hard labor night and day with power drills and a resort to an entirely new method of driving spiling and setting breastboarding to get one set of timbers. And in this place, it cost $3,500 per foot. Spiling and breastboards, you probably don't know what those are, but here's a drawing from a book on timbering that was published by the Idaho Bureau of Mines and Geology in 1958. You can see on the top, there's kind of a cross section looking along the tunnel. You can see the posts with the caps on top of them. But also these posts and timbers have a bridge block so that they can set another cap or a brace down lower along the side posts. And then they put a spile on top of that. A spile is a plank, usually a piece of lagging that's been sharpened on the end. So before they would blast in this soft ground, they would drive that spile ahead into the soft ground, and it's the weight that it supported would be cantilevered back onto the post or the timber set that was already in place. This method was developed in the Mother Lode in California when they had gold-bearing gravel deposits that were too deep to be mined by placer mining methods, so they mined them using spiling like this. And sometimes, if you can see in that top drawing, they would even put in what was called a false set to give extra support to the spiles as they drove them in. Now, if you look at this cross-sectional view, you see they didn't just put in one spile, they put in a whole row of them. And breastboarding was done, especially in soft ground. As they would move into a soft face, they would put breastboards, again, probably the 2 or 3 inch by 10 inch lagging, they put those up against the posts at the bottom so that as the soft ground flowed, it would be retained by that breastboard. And then as soon as enough material flowed out, they'd put another breastboard in a little further in, and they'd set a sprag, piece of wood, between each end of that breastboard and the sideboards. And they put these breastboards on up. So there was a lot of technology, and again, a lot of material, a lot of work put into to hold this face. In Park City, the spiles were made from carefully selected timber, capped with iron and driven by compressed air. And in addition to the breastboards, they would often put large sacks of hay in front of the breastboards and pack them down. And that would help to hold this soft flowing ground. There was one report that said often as much as 40 or 50 cars of sand and gravel, wet sanded gravel, would escape through a crevice that was not large enough to admit the passage of a man's hand. Now, 50 cars would be 50 tons of sand or gravel just flowing out of the face. So you can see why it took them so long in some of these soft and loose ground sections. They also would have to try and take the water away from the face. At one time, they would drive some drifts alongside of the tunnel to try to drain the water, but that didn't work. And finally, in 6 of the spots, they actually drilled holes in the breastboards, in the side drifts, and in the lagging to let the water and the sand flow out of those. And then they'd have 6 or 8 men working with bars to keep those holes open. So there was a lot of effort put into opening this tunnel. Just to finish up the year of 1894, on October 20th, there was a dance at Keetley, and several couples came from Park City. Rather than going around, by road, they rode the hoist down the shaft and came out the tunnel to go to the dance. It's interesting to me that Superintendent Keetley had a fistula removed on October 27th. Apparently he had suffered from that for over a year, but didn't want to have the operation until the tunnel was done. There's some endurance there. By November 3rd, they decided to continue the tunnel to shaft number 3. They were talking about giving the boys the day off so they could vote. They decided to construct a power plant at the mouth of the tunnel, and it would light the Ontario and the Daly mines and the Marsac and Ontario mills and the Ashholme Merck building. They figured they could complete that plan in 30 days, and they did. They had 100 horsepower from the water flow with 2 Pelton wheels to drive the dynamos. It was just interesting to me. Shortly after the tunnel was finished, people started fighting over who owned the water in it. If you've been in Utah very long, you know there's always a fight about who owns the water. In particular, there were some lakes up on the divide between Park City and Midway, and the people who owned those water rights said that water was going into the tunnel and the mine couldn't keep it. So the story's a long one. Eventually there was a lawsuit, but it was just interesting to me that came up so quickly. So here's a summary of the tunnel, 15,400 feet long to the bottom of number 3 shaft. And we've also talked about the dimensions already. The cost, I never find a firm number for the cost, but it was estimated at $400,000. And that's equivalent to $10 million today. But it was reportedly that was paid back in 3 years. So it was worthwhile. Now here are some photos just of the area around the Ontario, some from the old days and some from when I visited there in 2001. This is the office building. I couldn't find a date on this photo, but it looks like Park City in the winter, doesn't it? And this is that same office building when I visited there. You'll notice that the sign above the door now says Park Utah Mining Company. By 1922, a lot of the mines have been consolidated. This is inside that office building. There's R.C. Chambers in the center. Mustaches were very popular in those days. So you see everybody but the lady had one. This is looking from the tunnel mouth down out to where Jordanelle Reservoir is now. You can see the shaft house for number 3 shaft with the chimneys there at the right, and you can see all the timbers stacked up in the foreground. This is another view from slightly higher up with some more buildings in place. Again, you can see the shaft house here on the right, and you can see the tramway going across to carry ore, and again, big stacks of timber that they used all the time. This is the laboratory at the assay lab. Maybe the fellow on the right's too young to grow a mustache, I'm not sure. This is the tunnel mouth in 2001 when I visited there. It looks about the same. You can still see the 18 gauge rail coming out. And then there's another view just to see the buildings. I don't know if anybody's been into that area lately, but when I went there in 2001, you could kind of sneak in and the water was running out in Jordanelle Reservoir. When we went in the tunnel to inspect it, this was a crosscut that was about 1,000 feet in, and the water coming out of there was about 4 feet high. So there was still a lot of water flowing out of that tunnel. These photos just give you some idea of the loads that the timbers were taking. There's a 10 by 10 inch post that's failing in tension. It's just cracking. There's another post that's failing in compression, which is a rare thing in wood, but it does happen. This is an interesting one because this is a bulkhead that was put in place when they were driving around the cave-in. These are 12-inch steel pipes that were filled with concrete. You'll notice that the vertical one is still round, but that top pipe has, with the concrete inside, has been crushed by the weight of the earth resting on it. So we could do the calculations and figure out what it would take to crush that much concrete, but it's a lot. And if we have time sometime, I'll give another lecture on what it took to drive around the cave-in in this tunnel. It's another interesting story. So to conclude, I just mentioned that in Cornwall for many years, they operated without hoists, and they were mining mostly these inclined lodes. And this is the Dulcoth lode again, which is a very thick, very rich copper tin lode. And the miners went to work by climbing down ladders, sometimes as far as 1,500 feet below the surface. And when the shift was over, they would climb out the ladder, but being cheerful Cornishmen, they would say in their dialect, "I'm going to grass." So that meant they were going up to where the grass grew. And that's the end of my presentation. Answer questions.
Mike, that was excellent.
Diane or Donovan. So thanks.
Yeah, that was excellent, Mike. We open it up to questions. If you've got questions, you can perhaps hit the chat button, I think, and then we'll call on you. Could I just add a quick one while we're waiting for the questions? What was the purpose of when you were employed by the city or the Olympic Committee? It was just inspecting the stability of the. Why did they want to look at the tunnels in particular?
Right, good question. So the Ontario Tunnel inspection, the Jordan Water District down in Salt Lake Valley was thinking of buying some of the water that came out of the Ontario Tunnel, and they wanted to know if it was likely that that tunnel would stay open or if they would have to maintain it and what the costs would be. So I went in with a geologist and a couple of others, and we gave them an estimate of the stability of the tunnel and the timber sets and so on, and the cost to maintain it. When we inspected the Daly Judge tunnel the next year, that water is used by Park City Municipal Water District for the city's water supply. And the water that comes out of both these tunnels is incredibly clean. It far exceeds the EPA's drinking water standards. But in both tunnels, if one of the timber sets fails, or one of the roof supports fails, then there's a cave-in, and that stirs up a lot of dust. And the dust in these mines, it's wet dust on the floor. But because these were lead, zinc, silver mines, that dust has a lot of things like lead, zinc, cadmium, and arsenic in it, enough to contaminate the water. So in 2002, the city water district was concerned that if there were a cave-in while the city was full of Olympic visitors, they wouldn't have enough potable water to serve the people. Mm-hmm. So, and that could be even another presentation. Went in with the team and inspected the timbers all the way to the back, and then we recommended which timber sets needed to be replaced with steel sets, and then supervised that work. And that was quite interesting to see, how the present day miners put in I-beams instead of 10 by 10 inch timbers and how they did that work. So that's a long answer to a short question.
We have a question from Annie Lewis. She says, how did ownership of the water evolve?
I only read the record up until 1908 when they got around the cave-in, but the Ontario eventually bought out those people who had filed on the water on the lakes, and they gave them, I think, $3,500, plus they allowed them 1/3 of the water that came out of the tunnel. But there were continuing complaints. The miners in the Jordanelle Valley and any place where that water went were complaining that it was contaminated with metals, and they were suing the Ontario. And even just in that short period of time from 1894 to 1908, I think there were 6 or 8 entries about various disputes about who owned the water and whether or not the mine was contaminated. So these issues continue today.
There's a question from Brian Buck. Did the Ontario drain tunnel also drain the Daly and Daly West mines?
Yes, it was eventually extended over there. And that was a big thing because besides draining those mines, it also allowed the Daly and the Daly West to haul their ore out through the tunnel instead of hoisting it to the surface. And when those 2 companies merged, which was not long after the tunnel was extended, then it really increased the economy of the Daly and Daly Judge operations, Daly West.
Another question from Sandy is, was any commercial value ore found during the driving of the tunnel? Did they find any extra veins or ore that they weren't aware of as they went in?
They found some. They hit a vein, as I recall, they were about 1,200 feet in, and they hit a vein that they weren't aware of. And when that word got out, all the ground along the path of the tunnel was staked in about a week. But after that, they didn't encounter very much ore. So it was, okay. I haven't read the geology reports, but based on what was said in the park record, that ledge that they encountered early on was something of an anomaly.
Another question from Brian. Does the Alliance Tunnel still discharge water?
I don't know the answer to that. So I had intended to get up and try and poke around all these tunnels before this presentation, but I didn't make it. Maybe somebody from Park City knows the answer.
Does anyone know an answer to that one? Who's out there?
No.
Any other? I just got a comment from Richard saying, thank you, a great presentation.
Thank you.
Do you want to talk about the Midway tunnel at all? Because I know that that's not part of your presentation, but I know there was lawsuits that went to the Supreme Court on the water issues.
That's on the Snake Creek Tunnel?
Snake Creek Tunnel, yeah.
Yeah, you know, Donovan, I haven't looked into the history of that one in much detail at all. I'm thinking, you know, being an academic, with all I learned just getting this presentation together, we could do an entire book on the Park City drain tunnels.
Yeah, yeah.
Probably it would sell 1,000 copies, but it would be worth it. No, I did go in the Sparrow Tunnel in 2007, and again, they were concerned about the risk to the water supply of a cave-in in there, and we wrote a report for them and then didn't hear back. So there's some soft ground in the Sparrow Tunnel too that is held in place with roof bolts on 1-foot centers and chain link. And yeah, there is some risk with that tunnel.
Sorry. There's a question from Pat Pond. In the late 1800s, a mine down south collapsed and caused an earthquake estimated to be about 6.0. Is there any danger of mine collapse causing an earthquake here?
Yes. I don't, I'm not aware of any collapses for a long time in any of the Park City working. And Utah Seismograph Station, that's part of the College of Mines that monitors earthquake activity all over Utah and the neighboring states. There have been earthquakes caused. The most recent one that I'm aware of was caused by a collapse. It was an engineered collapse. It was meant to happen in lines by Green River, right? The collapse was meant to happen a little faster, a little larger scale than expected, and that but we have an ongoing study with the National Institute of Occupational Safety and Health to study mining-induced seismicity, and it is a definite thing that we need to be aware of. So, but as far as Park City tunnels, I'm not aware of any earthquakes that have been recorded as a result of collapses there. But I've never asked at the seismograph station. I'll have to ask him when I'm up there tomorrow.
There's another question from Brian. Many of the Park City mines use stope backfills that would reduce the future potential of massive collapses. I guess that's a comment that there was.
Yeah,
they were
and that is true. And
yeah.
if you look in the photos, Park City Historical Society, there are some photos of workers stowing backfill into some of the open stopes.
Yeah. Well, any other questions? We're about almost to 6 o'clock. Mike, short of any questions, I just want to thank you for a great presentation. You've a lot of great detail in there and really useful stuff. And thank you for your knowledge plus all the research you did in the park record. It's an excellent talk. Thank you.
No, Donovan.
On behalf of all of us, thank you. I appreciate it.
All right. I forgot to say what top car meant.
Yes, you forgot. Yeah, can you?
So when the ore cars would come out of the mine, they would be hauled out, either pushed by a miner or hauled out by mules to the ore dump, and the top car men would dump those cars. Some of them, they had a dump mechanism. They'd either dump from the side or from the end. And by the time my grandfather went to work in Park City, he was 45 and he wasn't strong enough to work underground. That was the main criterion for an underground miner, was strength and endurance. So the older, weaker miners worked top car. And for a lot of them, that wasn't as desirable a job because you were outside. It was wet in the mine, but the temperature there was pretty consistently between 35 and 40 degrees Fahrenheit. But if you were on top car, you were out in the open even during the winter. So
I should relate another amusing story from yesterday. I mentioned that was a group of us were at the Silver King mill and at the shaft yesterday, and I was looking at some old drawings. Actually, Brian Buck had supplied me some. I think it was from 1929 of the surface facilities, and I saw a reference there to a hog pen. And I had, I've been a mining engineer in my life, and it's a term a mining term that I had not heard before. So I got onto Google, and I Googled hog pen and didn't find anything. Anyway, I talked to Sally Elliott yesterday. I said, Sally, do you know what the term hog pen is? She said, yeah, it's a pen where they keep hogs. I guess the miners who were in the bunkhouses or out, on the surface outside the Silver King on the shaft area there, like pork, I guess, and they had a ready supply of pork, and they fed the pigs from all the waste food that came from the bunkhouses. But I thought I was going to learn a new term, hog pen, but it actually meant the place where they kept the hogs.
Yeah. That's it.
Mike, thanks again.
You're welcome. My pleasure.
Yeah, and then we're going to get you back and talk some more about some of these other tunnels as well. But that was an excellent presentation. Thank you, and thank you all for listening. Another Friends of Ski Mountain Mining History lecture series. We've got another one coming up where we're actually going to present, or Sally and Don are going to present. As well as some other people, JR, and the people who've worked on the project, an explanation of the projects that we've done over the last 5 years, and also the projects going forward. So that'll be a good presentation. And then following that, we've got Brian Buck's going to give a talk on the Daly West, and John Daly and the Daly West operation. So thank you all for listening in, and we appreciate your support. And if you need it to find out any more about us, go to parkcityhistory.org and look under Friends of Ski Mountain Mining History. And also thank you to Diane again for organizing the technical part. And we did pretty good. It's a little new to me, but Mike is a lot more familiar with this with his lecturing background, but I think we managed to succeed. So thanks a lot, everyone.
Thank you, everyone.
Again,
Thank you
Mike.
all. Thanks again.
Mike, thank you.
You're welcome. My pleasure.
That was very good. Yeah, well, it was great talk. A lot of information that you got there on and it was very good.
That was really interesting.